In this video, we will be discussing multiplication and division in algebra, specifically the ideas of exponents and cancellation. Let's consider the expression x times x. Is there a way to rewrite this, to simplify it? Well, as you probably know, when you have two of something and you multiply those two somethings together, it can simply be represented as x raised to the power of 2, or x squared. Similarly, if you have three x's being multiplied by each other, that can be represented as x raised to the third power, or x cubed. Now let's say we have x times x squared. How would we rewrite that? How would we simplify it? Well, we know that x squared is simply a stand-in for x times x. So this expression is the same thing as x times x times x. And as we showed here, x times x times x is equal to x cubed. Now, x can be thought of as x raised to the first power. And if you notice, the exponent of our solution is equal to the sum of these two exponents here. X raised to the first power plus x raised to the second power equals x raised to the third power. This rule can be generalized in the expression x raised to the a power times x raised to the b power equals x raised to the a plus b. Let's say we had the expression x squared times x cubed. The solution, what would the solution to this be? Well, we have 2 and 3 as our exponents, and our rule says that all we need to do is add our exponents together. So x squared times x cubed will give us x raised to the 5th power. What if we had a term to simplify that didn't just have one variable, but had multiple variables? Say we had x squared times y times x cubed times y to the 5th. How would we simplify this expression? Well, we know that if we multiply two things that are the same but just raised to different powers, we know that we just take the sum of their exponents. So x squared times x cubed is x to the 5th. And remember, a lone variable can be thought of as that variable raised to the 1, so y is also y to the 1st power. So y to the 1st power times y to the 5th power would be y to the 6th power. And the reason that this works is that this expression on the side can be rewritten as x squared times x cubed times y to the 1st times y to the 5th. Remember, when you're multiplying, the order of your terms really isn't that important. It doesn't matter. They still will come out to the same solution. So y to the 1 times y to the 5th is just y to the 6th. Y squared times x squared times x to the 3rd is just x to the 5th. So this is just x to the 5th times y to the 6th. Now, it is possible to have an exponent with a negative value. So how do we use this rule when we have exponents of negative values? Let's rewrite our original expression as x squared times x to the negative 3rd. What is that equal to? Well, according to our rule, we just add those exponents together. Okay. 2 plus negative 3 would give us negative 1. Now, how can we rewrite x raised to the negative 1? Well, we rewrite it as 1 over x. So that's interesting. What if we did x to the minus 2 times x to the 3rd? What would that be equal to? Well, let's follow our rule. We'll do a negative 2 plus a 3. That gives us a positive 1, which x raised to the first power is just x. Cool. What if we had x to the negative 2 times x to the negative 3? Well, negative 2 plus negative 3 is negative 5. X to the negative 5, or 1 over x to the 5th. So this is how you deal with negative exponents, and you can see you can get lots of different answers, lots of different types of solutions. And the idea of negative exponents actually ties in slightly to this idea of cancellation and division in algebra. So let's talk about division and cancellation. Let's say you had, this expression, a times x over a. Some fraction here, a times x divided by a. This can be rewritten as a divided by a times x, which in turn can be rewritten as 1 times x, because as we know, if you divide something by itself, that just equals 1, and 1 times x is just equal to x. So what the effect of this is that if we go back to our expression here, we get something called cancellation, where if you have two things on the top and bottom of a fraction, they cancel each other out and just leave what's left behind. Now, what if you had the expression ax over a plus 1? Could you, in this case, cancel out these two a's? No, you can't, because we don't get this same type of effect here. What we would get instead is a over a plus 1 times x. And we can't do the same thing we did in the first example where a over a is equal to 1, because a over a plus 1 isn't equal to 1, which means this is not going to be equal to x, or to just x. Therefore, if you have a situation like this, these a's, or these terms, will not cancel out. Let's say we had the expression x times y divided by y times x plus 1. What things in this expression can we cancel, and what things can we not cancel? Well, the thing that we can cancel out are these y's here, because they're the same. However, we cannot cancel out these two x's. Remember, if you have something in a parentheses being multiplied by something else, this acts as its own thing, and x plus 1 is not equal to x. Therefore, the only things that cancel are these two y's, and we get our answer of x over x minus 1. Let's try another one. 2x over 2. To simplify this, we just cancel out these two 2's and are just left with x. What about 6x over 3? Can we simplify through cancellation? Well, at first glance, it might not seem like that there is anything on the top or bottom that's the same. However, this 6x can be rewritten as 2 times 3 times x, and that's all over 3. Now we have something on the bottom and the top that are the same, and that can be canceled, leaving us with 2x. You can also think of this as 6 over 3 times x. 6 divided by 3 is 2. This would also work the other way. If we had 3x over 6, how would that simplify? Well, you can think of it as 3x over 2 times 3, in which case you would cancel out these 3's and be left with x over 2. Or you can think of it as 3 over 6 times x. And if you remember your simplification of fractions, 3x is just equal to 1/2. 1/2 times x would give us x over 2. Let's say you had 2y over x plus 3 times x plus 3 divided by 4 times x plus 3. What here can we cancel? Well, in these parentheses, you can see that we have x plus 3. That means that these terms are the same, and they can be canceled. Now this 2 and 4 here, if you recall from the previous problem, you know that this is very similar to a fraction. 2/4 can be rewritten as 1 over 2. So this expression simplifies to y over 2. This method of cancellation can be applied to exponents as well, and can help us understand how negative exponents work. Let's go back to one of our other examples, one of our older examples, x squared times x to the negative 3. Now, according to our exponent rule, we could solve this just by adding these two exponents together to get x to the negative 1. But the reason that works is because of this. We can rewrite this expression as x squared over x to the 3rd. Remember, when you have a variable raised to a negative exponent, that just equals 1 over x raised to the positive exponent. And that's basically what we've done. We've taken x to the negative 3 and written it as 1 over x to the 3, and then multiplied it by x squared. So how does cancellation work in this case? Well, x squared is simply 2x's multiplied together, and x cubed is 3x's multiplied together. Well, we have one x here that can cancel with one of the x's, and we have another x that can cancel with another 1x. And what we're left with is 1 over x, which can be rewritten as x to the negative 1. Now, if we follow our exponent rule, which says to add our exponents together, we can see that we get 2 plus negative 3 will also give us an exponent of negative 1. So this is why the exponent rule works with negative exponents, because of this cancellation effect. So we kind of get a second part to our exponent rule. The first part was x to the a power times x to the b equals x to the a plus b. And what we just showed in the previous problem was that if you have x raised to the a divided by x to the b, you get x to the a minus b. And these are actually the same rule, just written in different ways, because x to the a over x to the b can be rewritten as x to the a times x to the negative b. And following our first exponent rule, we know that we would get x to the a plus negative b, or x to the a minus b. So really, the exponent division rule and the exponent multiplication rule are pretty much the same thing, just with an extra negative thrown in.